Here we're going to fill in the table for the function z equals absolute value of x plus absolute value of y. And then we'll try to plot it in both 2 dimensions and 3 dimensions in a couple of different ways. So first thing I'll do is just add the magnitudes of all these numbers. Let's see, 0 plus 0 makes 0, 0 plus 1 will be 1, 0 plus 2 is 2. We don't want to have any negatives here. Alright, so we can see a sort of diamond pattern emerging. And it looks like that pattern's just going to keep building outward. Alright, and I'll use the convention of just shading in dark squares for low elevations. And then we'll do lighter squares for higher elevations. Okay, that's the shading that I get. Now let's draw a series of what are called level curves. Level curves are, to make an analogy, like a topographical map. They're curves which all have the same z value. And before I draw them, it could be helpful to just use the online CalcPlot 3D app to draw the level curves. Let's see if we can do that. So first, let's put in our function. And yeah, that's a strange looking function. Alright, now in order to get the level curves, one thing we could do is we could add more functions. And the idea is we could create several planes. At different z values. And level curves will be the lines where the planes intersect with our surface. That's the idea. And as you can see, they're going to be sort of diamond shaped. Let's see how else we could draw the curves though. Okay, so let's go ahead and click on this contour plot icon. Now this will allow us to set different level curves, and those will be the values of C, and they'll be the contours that get drawn here. It's going to create a two-dimensional map. So our first level value should be 0 because that's the lowest z that we had found in our table. Now for step size, let's do a step size of 1. Here's why. They're looking for a k value of 0, 1, and 2, but the k is the height of the level curve. Now how many do we want? Well, let's just do those 3 for now. Okay, as you can see, it's now modified our C values, and these are basically like the K values, same thing. And we want to show the contours on the surface itself. We could project the contours onto the XY plane. That's one option. Okay, let's try that. Okay, by default, it's going to show you a top-down view, but we can also rotate to see our level curves in 3 dimensions. And we can choose to have the surface showing, or we can hide it. Let's try it with the surface showing this time. Yeah, and so you can see that the level curves are like topographical lines on a map. All the points on the level curve have the same elevation. It's an elevation of 2. Then when we look at this level curve, it's got an elevation of 1, so it's lower in height. And then here is the level curve for 0. It's just a dot. And that's the lowest valley in our surface. Okay, so we want to create that same kind of map. And in order to do this, we have to substitute in the values of k. So let z equals 0. Then you'll take your original function, plug in a 0, and then try to solve it. So since these are absolute value signs, they would take away any negatives. That means neither of these terms could be negative. There's only one solution to this. X equals 0 and y equals 0. It's the only possibility. So for my k of 0, I'm going to put that one down here, and it's just a single dot. Now let's let z equal 1. 1 equals absolute value of x plus absolute value of y. I'll try to solve it. And absolute value equations can be a little tricky to solve here. Notice here, though, that this equation would only hold true if x is between -1 and 1. Y equals 1 minus x, or y equals -1 minus x, which simplifies to x minus 1. Now let's try to rearrange here. Okay, now what are the restrictions? Y has to be between 0 and -1 for this equation to work. Here, our y has to be between 1 and 0. So we want to use this formula when we are in the negative y. We want to use this formula when we're in the positive y. So y equals 1 minus absolute value of x. So when we're in the positive y, we're going to need this. When we're in the negative y, we'll need this. This is for k equals 1. And if we solve the same system of equations for k equals 2, we'll just get a larger diamond. All right, so those are 3 level curves for this function. Now, now I want to plot my level curves in 3 dimensions in a similar way that the online apps display them. I'll put k equals 0 here, k equals 1, and k equals 2. Now notice the orientation of the axes. This is the positive x direction, and this is the positive y now. But if you remember, for k equals 0, it was actually just a single dot at the origin. So that's what we'll want to put here. A single dot. For k equals 1, we have a diamond shape which touches these points. And it looks like that. Then for k equals 2, it's twice as big. And there we go. So our last job could be to draw the actual surface. And that could be a little tough to do here. But basically we want to just connect as best we can. And there we go. Now the final step of drawing a contour plot is to take your k equals 0, k equals 1, k equals 2 and project them. By projecting them, I mean we're going to move them down to the bottom plane. We want to bring our k equals 0 down. We'll bring our k equals 1 down too. And we'll bring our k equals 2 down. All the level curves get drawn now on one coordinate plane. And that is a contour plot. It's like a topographical map for a 3D function. Let's draw it. We'll label our k values. And it's done.